Hi guys, welcome to chapter 8, part 2 of our elements of programming. And today we're going to talk about pointers, arithmetic, and passing addresses, right? So, still in pointers, right? And, and we'll talk about some of how we use pointers to do some passing of addresses, right? And okay. So, in this chapter, basically, we'll talk about pointer arithmetic, passing addresses, and some of the common programming errors. Right? Now, you know, one of the idea of having pointers is, capable of creating variables, during runtime, right? Or creating memory locations during runtime. So the problem was using variables is nice, but we have to basically define it before the program runs, right? So we have to compile it in such a way that those variables are defined early on, right? So and using pointers basically help you in creating arrays during runtime here, right? So let's talk about let's think about that for a bit. But now we're going to talk about a bit about static array allocations. So as variables are defined, right? Particularly the compiler creates a storage which assigns to a particular memory pool, right? So specific memory locations are fixed for the lifetime of the program, right? For the variable, right? Whether it's used or not, right? So when we already define the variable and it runs, right? During the execution, the compiler creates these memory locations for the lifetime of the program, right? To be used, right? Or even if it's not be used, those locations are pretty much created for that variable, right? So for example, if we want to handle to store 500 integers, right? We have to define it early on, right? That the array has 500 integers, right? Um, so what would the compiler do is the compiler would allocate memory for 500 integers, right? Even if the storage is not used, right? The storage is not released until the array goes out of scope, right? So until the array, the lifetime ends for that particular array, right? If more than 500 integers is required, right? Then the array size must be increased and the program has to be recompiled, right? And we cannot really create this during runtime, right? We cannot simply change 500 integers to 1000 integers, right? If we have less, this is okay, but there's wastage because we have allocated memory that we don't use. If we have more variables that we need to allocate, we cannot allocate it during runtime, so we have to recompile the program, right? So that next time it runs, it knows to load more variables, right? So dynamic array allocation, right, is determined and adjusted as the program is running, right? So this is useful when dealing with particularly a list, right? Now a list allows you to expand and contract the list items and add it to it or delete it, right? So this is nice because we can have a list without a very specific defined size, right? As opposed to an array, right? And if we have 5 items, then we only need 5 memory locations, right? And if we need more, we create them on the fly as the program runs, right? So we need a new a method to add new or delete new memory locations, right? So that we can grow or shrink an array, right? Okay. So in arrays, basically it allows us to have this an operator called new and delete, right? The new operator reserves the number of bytes requested by and returns the address of the first reserved location, right? And delete basically release the block of bytes, right? Reserved previously for a particular address, right? So okay, so now um, so here we have a example here. We can have a we can assign a value to a pointer upon declaration. For example, int star num equals to new integer, right? So this would reserve space for an integer variable, and we store addresses of this variable into the pointer num, right? um, so example 2 here, same function as example 1, right? But we declare the pointer first, and then we assign the pointer to a new integer, right? Now remember, when we run a program, right, and when we write a program and we compile it, right, it will create the basically the binary instructions, right? And when we run it, basically we are instructing the computer to allocate certain memories, right? Now what about stuff that is not allocated, right? And we call this unallocated memory. And this storage, this area where we can have unallocated memory is called the heap, right? Where it is basically a free storage area of a computer, right? And we can use it to allocate unallocated memory, right, during the runtime, right? So it's quite different here from how we are using variables before, right? So in example 1 and 2 earlier, right, basically we are creating new storage that would be allocated in the heap area, right? So this creates a new integer, right? New integer storage, right, which would be accessed through this pointer, or we create a pointer that that is allocated to a new memory, a new integer that's being created, right? Now so what about an array, right? So if we need more array, we can use the star pointer, right? So if we need a grade to have 200 integers, then we would create a new integer array of 200 and assign it to a pointer, right? This statement basically reserves storage for 200 integers and places address of the first integer into the pointer grade, right? So this is a nice thing, right? And we can do this during runtime itself, right? So when we can write a program in such a way, we can ask the person of how many grades that they want to enter, right? And create the array on the fly, right? So star grades equals to new integer num grades, right? Which would basically allocate whatever number of grades that we want to enter, right? So the size of the array depends on the user input and not as you define it in the beginning, right? And this is a nice thing, right? Now we can access the values of the arrays to the notation grades and the index, or the pointer notation, right? Star grades plus I, right? Okay, So here is an example of a dynamically array allocation at runtime, right? So notice that we didn't define any array here, right? But we asked for the number of grades that we're going to enter, right? And here we're dynamically creating the array, right? Not during compile time, right? So we don't know the size of the array, right? We only know it during runtime as the user enter the input, right? And after the input is entered, then we can loop through it via using grades plus I, right? Which is a pointer to the variable and some offset value, right? Okay, so that's nice, right? So next we'll talk about the pointer arithmetic, and I'll see you in a bit. We'll take a short break for now, and we'll continue for pointer arithmetic in the next section, chapter 8, part 2, section B.